Investigating force, mass, and acceleration. In the previous tutorial, we explained how to get the acceleration using this experiment and how I can draw a graph between acceleration and force. And now if we go back to the book in figure 3.4, we can see that this acceleration force graph is an increasing straight line passing through the origin. This shows that as force increased, the acceleration also increased. So we can say that the force is proportional to acceleration. And the proportional has the following symbol, so we write it as follows. In the experiment, we saw the effect of force on acceleration. Now let's see the effect of mass of an object on its acceleration. The accelerating force is kept constant and the mass on the trolley is varied. This happens when we use the same loads through the experiment. This caused the load force or accelerating force to be constant, whereas we change the loads on the trolley. So we repeat the experiment by changing the loads, and at each change we measure the acceleration. Then the acceleration for a particular trolley mass will be found. After we get the acceleration and we have the mass, we can draw a graph between acceleration and mass. We can see this graph in figure 3.6. Now we notice that as mass increases, acceleration decreases. In this graph of A against M, now plotting 1 over M gives a straight line. This makes it easier to spot the way that A is affected by M. So if we draw the acceleration with respect to 1 over M, we notice that it is an increasing straight line passing through the origin. So we can say that the acceleration is inversely proportional to the mass. That can be written in this way, proportional to 1 over m. So at last we have the equation between force, mass, and acceleration. We have a force F in newtons, the mass m in kilograms, and the acceleration a in meter per second square. So F equals m times a.